Hello, dear students. This is the 11th class of Fourier transformation. Myself, Dr. Balbim Saimanna, Assistant Professor, Department of Mathematics, Government Science College, Autonomous, NT Road, Bengaluru. Now, in the previous class, what we have did means we have studied the Fourier sine transformation and the problems on sine transformation and inverse sine transformation. Let us go to one step ahead, that is the Fourier cosine transform. The Let me know that what is the meaning of Fourier cosine transform. Definition: Fourier cosine transform of f of x when x is greater than 0 is defined by like this: fc cap alpha is equal to fc of f of x equals to root 2 by pi integral 0 to infinity f of x cos alpha x dx. This is equation number 1. Now remember, this is the Fourier cosine transform. Let me discuss one more transform. This is the inverse Fourier cosine transform. F of x is then denoted by like this: f of x is equal to fc inverse of fc cap alpha equals to root of 2 by pi integral 0 to infinity fc cap alpha cos alpha x df d alpha, called equation number 2. Now these are the two important. This is the Fourier cosine transform. This is the inverse Fourier cosine transform. What is fc represents here? Cosine. In the previous class, in place of c, there is a s is there. That indicates sine transform. Now basic properties, linearity property. If a and b are constants, then for any two functions f of x and g of x, first one we have to prove that fc of a f of x plus bg of x is equal to a fc of f of x plus b fc of g of x. That is equal to a fc cap alpha. Fc cap alpha is written as, look here, fc of f of x is written as fc cap alpha. So here fc of f of x, we have writing fc cap alpha plus b as it is. Then fc of g of x is written g c cap alpha. Second one, fc inverse of a fc cap alpha plus b gc cap alpha is equal to a fc inverse of fc cap alpha plus b fc inverse of gc cap alpha. Let us prove one by one. First one, by the definition of the Fourier cosine transformation, as we discussed in the first one, here this one, fc of a f of x plus bg of x is equals to, then by definition, this one, fc of f of x is root of 2 by pi until 0 to infinity f of x cos alpha x dx. Here what is f of x? In the place of f of x, here a f of x plus bg of x. There f of x, again replace right hand side also, a f of x plus bg of x cos alpha x. Then next we write the separate of the terms. That means 2, here we have a sum of two terms. You write sum of two terms separately. This integral square root of 2 by pi into this and this, you will get this one. A times of integral 2 to square root of 2 by pi integral 0 to infinity f of x cos alpha x dx plus root of 2 by pi integral 0 to infinity g of x cos alpha x dx. By using the definition of the Fourier cosine transform, except this a and b, look this one. It is the fc of f of x. Here f of x is there, we have writing fc of f of x. Here function is g of x is there, we writing b as it is fc cap g of x. I once again repeat it. How we write this integral? By using the definition of the Fourier cosine transform. This total is fc of f of x. This total is fc of g of x. Therefore, this is left hand side as it is for the previous slide. fc of a f of x plus bg of x equals to a, here a as it is. This fc of f of x is written again in terms of fc cap alpha plus b as it is gc cap alpha. This is the proof of first one. Second one, from the first we know that a f of x plus bg of x is equal to, already we have proved this one. Just this fc you take right hand side, you'll get fc inverse from this proof of 1. Then a f of x plus bg of x is equal to fc inverse of a fc cap alpha plus bc cap alpha. Then this fc inverse of AFC cap alpha plus BG cap right as it is, then A as right as it is, FC inverse is multiplied by FC cap. Then A FC inverse of FC cap alpha plus B FC inverse of GC cap alpha. It is the proof of the second. Then go to the second property. What is the second property? That is change of scale property. If A is any non-zero constant and FCF f of x is FCF alpha, it is the definition of the Fourier transform, Fourier cosine transform. Then we have to prove that FCF f of ax equals to 1 by a FC cap alpha by a. Proof by definition of the Fourier cosine transform, FCF f of ax. In the f of ax place, what is there here? F of ax is there. That's all. In the Fourier cosine transform, wherever f of x is there, just to substitute f of ax. That's all. Then FCF f of ax is equal to root of 2 by pi until 0 to infinity f of ax cos alpha x dx. Now we should take the substitution this ax. Ax is equal to t. Then a should take right hand side, x is equals to t by a, and in differentiate x with respect to t. Then a is constant, 1 by a take right hand side, dx is equal to 1 by dt. Here x is varies from 0 to infinity. Then we are changing the x to variable t. Then t is also varies from 0 to infinity. So thus FCF f of ax is equal to root of 2 by pi as it is until 0 to infinity f of t. Ax is here, substitution t. Then cos of dx is equals to 1 by a dt. Then alpha is there, we'll get alpha t by a 1 by a dt. So t is the variable. This 1 by a is constant. You take outside the integral. Then you write 1 by a root of 2 by pi integral 0 to infinity f of t cos alpha by a. This t you writing the outside. This 1 by a you should write outside the integral. Then alpha by a t dt. Again look here, fc of a f of x. This is as it is in the right hand side. Again look this one integral. Wherever here f of x is there, f of t is there. Wherever cos alpha x is there, cos alpha is there. By using the definition of the Fourier cosine transform, then 1 by a as it is constant. This integral you written as fc cap alpha by a. By definition nothing but it is Fourier in the alpha. Here alpha by is there. That is why it is alpha by a. That's all. By the definition of the Fourier cosine transform. Next property, that is the shifting property. The statement of the shifting property is like this. If a is any non-zero constant and FCF f of x is equal to FC cap alpha. This is definition of the Fourier cosine transform. That's all. Then we have to prove that FCF f of x cos ax is equal to 1 by 2 FC cap alpha by a plus FC cap alpha minus a. So second one, we have to prove that FCF f of x sin ax equals to 1 by 2 times of fs cap alpha by a minus fs cap alpha minus a, alpha plus a, alpha minus a. Look here, compare this and this is cosine, this is sine. Here we use the, in this case, we use the 4 cos as well as the sine transformation. The first, by the definition, we have FCF f of x cos ax is equals to square root of 2 by pi until 0 to infinity f of t cos a t cos alpha t dt. This is the, by definition of the Fourier cosine transformation. Here in the place of f of x cos ax is there. Here in terms of x is there, that is you writing in terms of t in the right hand side, f of t cos a t. Then square root of 2 by pi as it is until 0 to infinity f of t as it is, cos a cos b formula it is cos of a t cos of alpha t. Use the cos of cos a cos b is equal to 1 by 2 cos a plus b plus cos a minus b. Then this simplification we are writing 1 by 2 cos of alpha plus a into t plus cos of alpha minus a into t dt. Then 1 by 2 is constant, take outside the integral. Then square root of 2 by pi until 0 to infinity f of t cos alpha plus a dt. Again this root 2 by 2 integral is multiplied. This term will get square root of 2 by pi until 0 to infinity f of t cos alpha minus a t. Again look here, except this 1 by 2, again this and this, by using the definition of the Fourier cosine transformation, we have write fc cap alpha plus a plus fc cap alpha minus a. Okay. Now by the definition, second proof. By the definition, we have fc of f of x sin ax is root of 2 by pi, square root of 2 by pi integral 0 to infinity f of t sin a t cos alpha t dt. This is the definition of the cosine here, cosine transform. Then root of 2 by pi as it is, 0 to infinity as it is, f of t. Then sin a cos b formula. Use the sin a cos b formula. That will get 1 by 2 sin of a plus b minus sin of a minus b. Using that formula, then this you can simplify. We write in this form 1 by 2 sin of alpha plus a into t minus sin alpha minus a into t dt. Then 1 by 2 you write outside the integral. Again this root 2 by this integral is multiplied. These two terms will get this one like this. Square root of 2 by pi integral 0 to infinity f of t sin alpha plus a t dt. Then this one minus root 2 pi integral 0 to infinity f of t sin alpha minus a dt. Again accept this 1 by 2. Again this and this by using the Fourier sine transformation. See very carefully here. Sine is there. When sine is there, we must and should use the Fourier sine transformation. Don't use the cosine transformation. So we have to write 1 by 2 fs cap alpha plus a minus fs cap alpha minus a. Now these are the three different properties. Then after learning these three properties, let us we go to some examples, work examples. First example, find the Fourier cosine transform of f of x is equal to x when 0 is less than x, x is less than 2. Look here very carefully, when f of x is equal to otherwise. The function is defining only 0 to 2 only. Other, if greater than 2, it will go to 0. We have fc cap alpha is equal to, this is the definition of the Fourier cosine transformation. Square root 2 by pi integral 0 to infinity f of x cos alpha x dx. Square root of 2 by pi as it is, like x is lies between 0 to 2. Here 0 to infinity, we changing 0 to 2. Here our infinity is 2. Then f of x is x. F of x is x. This cos alpha x dx as it is. So square root of 2 by pi as it is, to integrate this x cos alpha x dx by using the Bernoulli's rule. What is the Bernoulli's rule? Bernoulli's rule, we can integrate the two functions continuously. So x as it is, here x is the first function, cos alpha x is second function. X as it is, then integration of cos alpha x with respect to x, sin alpha x by x minus times of x differentiation 1. Then sin alpha x by alpha, this integration minus cos alpha x by 1 time alpha is there already, you get alpha square. Once again I repeat it, x differentiation is minus 1. Then in Bernoulli's rule, plus minus will continuously get it. Then minus cos alpha x alpha square integral 0 to 2. The next it is no term. Why? Because if we differentiate this one with respect to x, it will goes to 0. That is why there is a no terms in after this. Then upper limit is 2, lower limit is 0. Just substitute here square root 2 by pi. Wherever x is there, 2 sin 2 alpha by alpha minus into minus plus. Here cos 2 alpha by alpha square minus lower limit. This lower limit is 0 here, this one, because sin 0 value is 0. We have substituting this lower limit, upper limit separately. Cos 2 alpha by alpha square minus 1 by alpha square. Therefore, fc cap alpha is equal to root 2 by pi. Here 2 alpha sin 2 alpha plus cos 2 alpha minus 1. How will get it? You take the alpha square is LCM, alpha square is there. Then 1 alpha is multiplied by here. That is here 2 alpha sin 2 alpha plus cos 2 alpha minus 1 alpha square. This is the required Fourier cosine transform. Now let us go to one more example. Find the Fourier cosine transform of f of x equals to e to the power of minus ax when a is greater than 0. A is positive. Suppose a is 0, it is 1. A to the power of 0 value is 1. We can't find the Fourier transformation. We have, this is the definition of the Fourier cosine transformation, root 2 by pi integral 0 to infinity f of x cos alpha x dx. Wherever f of x is there, substitute the function e to the power of minus ax. That is root 2 by pi integral over the limit 0 to infinity e to the power of minus ax cos alpha x dx. So to evaluate this integral, use this formula. This formula is same as this one. Wherever a is there, wherever b is there, alpha is there. That's all. So integral 0 to infinity e to the power of minus ax cos bx dx value is a divided by a square plus b square. A divided by a square plus b square. Here root of 2 by pi as it is a divided by a square plus alpha square. This is the simple example. F of x is equal to e to the power of minus ax cosine transform. One more example, find the Fourier cosine transform of the function f of x is equals to 4x when x is lies between 0 to 1. F of x is equal to 4 minus x, x is lies between 1 to 4. When f of x is equal to 0, x is greater than 4. The solution of the, we have here three equalities are there. To write the Fourier cosine transform in this form, Fourier cosine transform is given by f sec of alpha is equal to root 2 by pi integral 0 to infinity f of x cos alpha x dx. So we are writing 0 to infinity square root of 2 by pi 3 times functions. One is 0 to 1, this one. Then if you consider 0 to 1 limit means you treat the function is 4x. So f of x cos alpha x dx square root of 2 by pi 1 to 4 f of x cos alpha x dx square root of 2 by pi 4 to infinity. X is greater than 4 means 4 to infinity f of x cos alpha x dx. So square root of 2 by pi as it is 0 to 1. What is f of x? I told here this f of x 0 to 1 limit means 4x. Then you are writing 4x here. And next it is 1 to 4, the function is 4 minus x. And 4 to infinity 0. The 0 is mean this total it is integral 0. Then these two integrals, by applying the Bernoulli's rule to the integrals, we get here 4x is the first function, cos alpha x is the second function. Using the Bernoulli's rule, we can integrate continuously. As we see the previous example, 4x as it is, cos alpha x, integration with respect to x, sin alpha x by alpha, then 4x is 4x differentiation minus 4, again sin alpha x by alpha is integration, I am talking, minus cos alpha x by alpha square, integral over the limit 0 to 1. Again do the same thing here as well, this integral. 4 minus x is the first function, cos alpha x is the second function. 4 minus x as it is, cos alpha x integration is sin alpha x by alpha minus times of 4 minus x, differentiation of this, 4 is 0, minus x is minus 1. Then again integration of this, minus cos alpha x by alpha square. The limit over the integral is 1 to 4. Just substitute in this integral, upper limit is 1, lower limit 0, here upper limit 4 and lower limit 1. So substituting the upper limit 1 here, we'll get 4 sin alpha by alpha minus into minus plus 4 cos alpha by alpha square. We are substituting upper limit continuously here, total term. And lower limit minus sin 0 value is 0. Then cos 0 value is 1. That is minus into minus plus 4 by alpha square. Root of 2 by pi as it is. Here is also substitute, upper limit is 4. Then 4 minus 4, 0. This total is 0 when substituting upper limit. Minus, again minus 4 cos 4 alpha divided by alpha square. X is equals to what here? 4. Minus 3 times of 4 minus 1, 3 here. Substitute the lower limit here, wherever x is there. Then 3 sin alpha by alpha, x is 1. Minus cos alpha by alpha square. Now look the terms you write together, 4 sin alpha by alpha, 4 cos alpha by alpha square, minus 4 by alpha square, because you took the square root of 2 by square root of 2 by 2 common here. So that's all. Then all the terms write as it is. Minus 4 cos alpha by alpha square, minus 3 sin alpha by alpha, minus into minus plus, minus cos alpha by alpha square. Then you write together 4 sin alpha by alpha minus 3 sin alpha, simplifier, this term and this term, you'll get sin alpha by alpha. Then 4 cos alpha by alpha square, 1 time of cos alpha by alpha, 4 plus 1 is 5. 5 cos alpha by alpha square, the remaining terms as it is. Then nothing but minus 4 by alpha square minus cos 4 alpha by alpha square. Now this is the required Fourier cosine transform of the given function. Let us go to one more problem. Find the infinite Fourier cosine transform of e to the power of minus x square here. E to the power of minus x square. The infinite Fourier cosine transform is given by fc cap alpha is equals to square root of 2 by pi f of x cos alpha x dx. Then root 2 as it is integral 0 to infinity f of x is e to the power of minus x square cos alpha x dx. This integral is to evaluated by using the Leibniz rule for differentiation under the integral sign. Then what we have to do means here both sides differentiate with respect to alpha d by d alpha of fc cap alpha. So root 2 by pi integral 0 to infinity dou by dou alpha e to the power of minus x square cos alpha x dx. Then root 2 by pi as it is integral 0 to infinity e to the power of minus x square as it is. Then only we differentiate partially with respect to alpha cos alpha x. We get minus sin alpha x into x dx. That's all. So root of 2 by pi. Then here what we are doing, just making the arrangement here. Multiplying by 2 here and dividing by 2. Then we get the same integral. Why? It is, you'll get the standard integral. That is we are doing. This 2 and this 2 get cancelled, we get same only. So this 2, you take left hand side, what you will get? 2 times of d by d alpha of fc cap alpha. Root 2 by pi integral 0 to infinity sin alpha x as it is. Then e to the power of minus x square minus 2x dx. So here using the integration by parts, so sin alpha x is the first function, e to the power of minus x square minus 2x is the second function. So first function as it is, integration of this, I am talking about integration of e to the power of minus x square minus 2x dx is, if you take the minus x square is substitution, minus x square is equal to t minus then minus 2x dx is equal to dt. Then it will vanish. So sin alpha x e to the power of minus x square minus 2x integration is only e to the power of minus x square. Integral 0 to infinity minus times of integral 0 to infinity integration of second. As I told, this integration is totally e to the power of minus x square. We can try roughly, we'll get it. E to the power of minus x square sin alpha x integration is cos alpha x into alpha dx, integration by parts. Here e to the power of minus x tends to 0 as x tends to infinity and sin 0 goes to 0. That means e to the power of infinity means 0. Then 2 times of d by d alpha of fc cap alpha, this is totally 0, this integral. Then minus root 2 by pi, this alpha you write outside the integral because x is the variable, integral 0 to infinity e to the power of minus x square cos alpha x dx. Now here this one, then what will be here? This is equal to this integral. Then this is minus alpha times of fc cap alpha. What is fc cap alpha? Fc cap alpha is here. Square root of 2 by pi f of x cos alpha x dx. Here in place of f of x e to the power of minus x square. Then we are writing in same this one. If f of x is substitute here also e to the power of minus x square, it will get the same integral. So then next what we are doing means here this 2 times of d by d fc cap alpha is equal to minus alpha fc cap alpha is there. No, this fc cap alpha you taking left hand side and this 2 taking right hand side. Then you get like this. Fc cap alpha divided by fc cap alpha is equal to minus alpha by 2 alpha. How will get is on integration. Then integration this you take, then you will get like this. If you integrate this one, then here fc cap alpha d means one time differentiation. That means f dash of x divided f of x integration is log of f of x. So here log of fc cap alpha then minus alpha by 2 integration with respect to alpha square by 4 plus log k. Log k is the constant of integration. So log of fc cap alpha, this log, you take left hand side means what will get? Log of fc cap alpha minus log k. Log m minus log n. Log of m by n form. You written like this. This is as it is. So fc cap, then this term you write in the exponential form. Then fc cap alpha by k is equal to e to the power minus alpha square by 4. Then what will get? Finally, fc cap alpha is equal to this k you should take right hand side, k times of e to the power of minus alpha square by 4. Then this is called equation 2. To find the value of this k, then put alpha is equal to 0 in equation 192. In equation 192. Then what will get? In equation 1 means this equation. This equation. fc cap alpha is equal to, we can put the alpha is equal to 0, you will get fc cap alpha is equal to root 2 by pi integral 0 to infinity e to the power of minus x square dx. But integral 0 to infinity e to the power of minus x square dx, it is a standard integral. This value is square root of 2 by pi, square root of pi by 2, sorry. Then root 2 by pi as it is. Then this integral value is root pi by 2. Simplify this, root pi get cancelled, 1 by root 2 cancel. Now putting alpha is equal to 0 in equation 2, in this equation, where this one. Then we get fc cap alpha is equal to k. Then alpha is 0 means e to the power of 0 value is 1. Then fc cap alpha is equal to k. Look from these two. fc cap 0 is 1 by root 2. fc cap 0 is k. Left hand side are equal. Left hand side are equal. Then k is equal to, right hand side must be equal. Then k is equal to 1 by root 2. Substituting this value in equation 2, where equation 2 is here. K is, what is k value? K is 1 by root 2. fc cap alpha is equal to 1 by root 2 e to the power of minus alpha square by 4. This is the required Fourier cosine transform of the given function. Let us go to one more example. Find the Fourier cosine transform of the function f of x is equals to cos x when x is less than 0 to a, f of x is equal to 0, x is greater than 0. The solution of this problem is, by definition, we have fc cap alpha is equal to, by definition of the Fourier cosine transform, root 2 pi integral 0 to infinity f of x cos alpha x dx. Square root of 2 by pi integral 0 to a. Here our function is defined 0 to a. F of x is cos x. So we are writing that only. Cos x cos alpha x dx. Then 1 by root 2, how will get it? Cos a cos b formula is 1 by 2 cos of a plus b plus cos of a minus b. That 1 by 2 is here. Using cos a cos b formula, you write 1 by 2 cos of x plus alpha x plus cos of x minus alpha x dx. 1 by, then simplify this. 1 by 2 into root 2 by pi, will get 1 by root pi, because root 2 get cancelled. Then here, integrate cos, it is, we write one more time, 1 plus alpha into x, 1 minus alpha into x. So integrate this with respect to x, will get sine of cos integration is sine of 1 plus alpha x by 1 by alpha plus sine of 1 minus alpha x by 1 minus alpha, integral over 0 to a. Then wherever x is there, substitute upper limit a, lower limit 0. 1 by root pi as it is, we are substituting x is equal to a here, sine of here x is there, substitute a. Sine of 1 plus alpha into a, 1 divided by 1 plus alpha plus sine of 1 minus alpha into a divided by 1 minus alpha. This is the required Fourier transform of the cos x when x is lies between 0 to a. One more example. Find the Fourier cosine transform of Fourier transform of the function f of x is equal to x to the power of n minus 1, n is greater than or equal to 2. By the definition, we have gamma function it is. It is the new one. This is gamma of n is equal to 0 to infinity e to the power of minus h x to the power of n minus 1 dx. Then substituting x is equal to I alpha t. X is equal to here I alpha t. This gamma function is written as gamma n is equal to integral 0 to infinity e to the power of minus I alpha t I alpha t raised to power n minus 1 I alpha t dt. X, what is x? I alpha. Dx is I into dl alpha dt. So I to the power of n, I will get it this. I to the power of n minus 1 I. What will get it? Simplify this I and I to the power of n minus 1. You get I to the power of n. Alpha to the power of alpha and alpha to the power of n minus 1. Alpha to the power of n. Integral 0 to infinity e to the power of minus I alpha t t to the power of n minus 1 dt. Because we have simplified this I alpha raised to power n minus 1, this I alpha. Then we have left only t to the power of n minus 1 dt. So since how we, by coming the complex number, this I can be written as I is the, it is the imaginary part. Cos theta plus I sin theta is the complex number, no? Cos x plus I sin x. But I is written as cos pi by 2 plus I sin pi by 2. How? Cos 90 degree value is 1. Sin 90 value is 0. Sorry, cos 90 degree value is 0. Sin 90 degree value is 1. So 1 into I. Then this is you write in the exponential form e to the power of I pi by 2. Like e to the power of I theta. Cos theta plus I sin theta. The same form is here. Then gamma of n is equal to alpha to the power of n e to the power of in pi by 2. Integral 0 to infinity e to the power of minus I alpha t t to the power of n minus 1 dt. Or the same integral we write in this form. Integral 0 to infinity e to the power of minus I alpha t t to the power of n minus 1 dt is equal to gamma n divided by alpha to the power of n e to the power of minus in pi by 2. Here, equating the real and imaginary parts separately. Then in the left hand side, integral 0 to infinity t to the power of n minus 1 cos alpha t dt, gamma n divided by alpha to the power of n cos to the power of n minus 2. Here, this one, e to the power of minus I sin e to the power of minus in pi by 2 written as cos n pi by 2 minus I sin n pi by 2. We are equating real part. Then we will get cos n pi by 2. Call this is equation. We are required to find the cosine transform of x to the power of n minus 1. Then fc cap alpha. This is definition of the Fourier cosine transform. Where f of x is there, we write substitute x to the power of n minus 1. But here we are writing in terms of t. This is the actually original. Then we are, this is the, it is the one more variable in terms of t. In the definite integral, we can change the variable x to t or t to x. Here x is there, we are changing the t. T to the power of n minus 1 cos alpha t dt. From the equation 1, we get fc cap alpha is equal to root 2 by pi gamma n divided by alpha to the power of cos n by 2. Because look here, this and this is same. Then this is equal to this one, fc cap alpha, which is the required Fourier cosine transform of x to the power of n minus 1. Okay, student. Thank you.